for a lot of our problems, they'll collapse pretty easily, yes. We're not trying to challenge you completely with. So if you guys get comfortable with the collapsing, work a few problems, you can probably somewhat come to expect that they will collapse pretty easy and get you onto solving it, because we're not this, really truly at the end of the day isn't meant to be a math class. It's meant to be connecting that there is something mathematical that supports the decision making going on. So Katie, getting back, I'm not sure I quite understood exactly what you're wondering here.
I think Jesse, I just forgot that a negative exponent means that it moves to the bottom.
Oh, okay. So you got to know those simple things.
Yeah, so as soon as she pointed that out, I was like, oh.
Well, I have a sheet that I made a long time ago, maybe even back in graduate school, but I also had a friend of mine that's taught different classes that made a sheet, but it's actually got a bunch of calculus stuff. But I remember the negative exponents. I think that might be something good to provide you guys. Like just to even have a cheat sheet that, not that I'd let you use it on a test, but even working through the homework, that you got this quick little negative exponent. What does that mean? Subtract them.
This has probably been a long time since I've been.
Because once you've got that, it's really not an advanced math maneuver. You just have to know. You just have to know how to handle that exponent. Okay. Other ones.
The last three, I kind of struggled with more of the like CDEs, like the last parts of the question.
Okay. The
and even looking at the back didn't help, so I didn't really.
Okay. So let's just start with number 14 then. Suppose the production function for iPods is this, the marginal product of labor and marginal product capital is this. Okay, what will be the firm's marginal rate of technical substitution? So you got that part okay. Part A?
Yeah.
Okay. And then where were you struggling when you get down to?
I guess I just don't know where like the 49 iPods come into play.
Oh, okay.
And how to come up with the lowest cost combination necessarily.
Okay. All right. So what you're missing is kind of the kind of putting the two parts of the puzzle together, I think. So the two pieces that are in play are the decisions at the margin to figure out what's optimal, which is where we deal with the slopes. In this case, we've got the slope of the isoquant and the isocost. So the marginal rate of technical substitution of labor and capital equal to the wage rate over the rental rate. There's our, and maybe put this one more thing here. We got the marginal product of labor over the marginal product of capital. This piece of the puzzle gives us the points of where we are for the optimal combinations of labor and capital. And then maybe what the part you're struggling on is what the isoquant really means. And so let me start there for this to try to address your question here. So the isoquant, let's see, what do we do? Q, is that the textbook notation? Yeah. So the isoquant of 49 units lies in here, and we can make 49 iPods. Is that what this problem is? We can make 49 iPods with a lot of capital and a little bit of labor, or a lot of labor and a little bit of capital. Right? So we're choosing the optimal combination of inputs to make this output. We do that by following the production function, which was this first equation of 20 to the k to the, what is it, negative 0.5, yeah, and L to the 0.5. So we solve up here for the optimal quantities, we plug them in, and we get our number. So for this one, Solve for the lowest cost combination of labor to capital that allow the firm to produce 49 iPods. Fractional units are fine. So did you get that part of the problem? B? Okay. So B is this part. Marginal product was given to us in the problem, 10K over L. Marginal product to capital is also given to us. So that's where we're going to be collapsing down the functions. Are you okay with that? So all you do is take this one step further, take those problems, put them over. Here, let me help, Katie, just so I kind of track with the rest of the class here. So marginal product, marginal, those are given to us in the problem. Do you got that down? Okay. And then that all collapses down to what? I don't have the answer in front of me here. And I don't, is that where maybe the answers in the back didn't quite track all the way down?
Do we need to know how to do that, or can we just know that it equals W over R?
It depends on what the question's asking. So in order to solve for that, we need to get it down to the W over R. But the problem, because we're asking for the optimal amounts, right? Let's see. What problem is this, 14?
14.
Okay. So let me just get a little more meat on this here. Okay, so that collapsed down to 2/3, right? The two marginal products equaled 2/3.
Is that just because that's
The K over L.
the K over?
Yeah. So getting to this step.
So the wage over the rent cost is equal to capital over labor?
That's our optimal condition, which comes from having our expenditure function, our ISO cost curve, which is the wage times the quantity of labor plus the rental rate times the quantity of capital, right? So that's the ISO cost line, which is similar to the budget line from utility. So that's our cost function, ISO cost. And then here's the ISO quant, the slope of which is equal to the ratio of the marginal products. So the slope of the ISO quant is the marginal rate of technical substitution. We're going to set that equal to the slope of the ISO cost curve, which is the wage rate over the rental rate. Make sense?
So it's the same thing as the marginal rate substitution.
Yep. And so that's why, yeah, you, and I guess both you two aren't maybe in those last two, but the videos are on there. This is exact problem really to utility maximization.
I don't know, so is W over R always going to equal K over L, I guess, is my question. Is that just that optimal point?
That's the optimal point. So it's always going to be equal to it at the optimal point, at the equilibrium.
Okay.
And it's the same problem that we saw in that test question, is if it's possible that there's an isoquant down here, of course, at 33 units, I'm just making up a number, and we're spending the same amount of money that we were if we were to compare point A and point B, and I said which point's better. Well, point A is better because we're getting 49 units spending the same amount of money. A and B are on the same ISO cost line, so we're spending, that's not optimal. We can get more units spending the same amount of money by increasing labor and decreasing capital. Change our input mix.
So the marginal product of labor over the marginal product of capital is the slope at point A.
Yes, so this is the slope of the ISO quant. ISO quant slope. And this is the wage rate
W over R is marginal cost.
Is the ISO cost, yep. All right. Looks like we're out of time today, so we'll just pick up there on Friday. We're going to be getting into chapter 7, so if you want to start looking ahead. What's that? Yeah, actually I'll take your homework and your tests, and if you had a question I can try to, I'll take your homework and your tests. But before you leave, was there other questions on the homework that we need to go over on Friday?
Yes.
The last three.
Okay, so we'll go over that when we get there.
Is there any way that I can keep my homework in, so when I watch the video, I can
Yes.
go along? Okay, I have it.
Okay. And I'll bring these back so we can go through them in class. I'll have them. Oh, yeah.
So, first of all, I didn't think the question even asked for the curve, so I wasn't sure it was perfect. And when you said that support my answer, that's why I didn't think points were necessary. I clearly labeled that A, and I can kind of put A and B together, and I put the C as further out in difference curve. So I got to kind of prove that.
I'll give you a point back. This was unclear to me, A and C, though, that's connected. I'm not going to give you full credit back, but,
What do you mean connected?
well, what is C, what is an indifference curve with
Bundle A and bundle
C? But that's not how we note it. I mean, so with the
So even if he knows that C
indifference
is the
curves.
answer, you still were looking for how we get there?
Well, yeah, I want some support for any answers on a short answer type problem. So, but yeah, I'll give you back a point. You were closer to having it, but if you take away my points there, it doesn't quite completely support why, and it's mostly because if you would have put like an indifference curve that has bundle C on it or something that supported it a little bit more.
Mine's kind of the same. I just was in a question. I don't even know if you can do anything for me or not, but I explained.
Yours was uglier than Adam's.
Yeah.
Because you had this.
But I explained the bundle situation where you can make an optional point.
Okay, I'll
We'll
take a look.
talk about it later.
Yeah. I'll look at it.